Hey guys, so in the last video, we ended up I kind of cut it short. So anyway, I wanted to start off here, and this is like really getting into the problems. So in this problem, you have you're trying to find a vector and you're given a magnitude and an angle. So think about that, length and an angle. So the first thing I want you to do is think about what I said, first of all, about the unit vectors. We're going to have that come into play. So if I have a 135-degree angle, it's going to be like, it's going to look like that. Okay, so I'm going to force this into the unit circle. And so even though notice that this length right here is 2, but I don't care about that. I'm just using this part of it. And the reason I'm doing that is because I'm using these values so I can, so my XY value, my X value is going to be the cosine of 135. And my Y value is going to be the sine of 135. And then, so what I'm going to do is I'm going to take this and I'm going to multiply it by my magnitude. And so what that's going to do is it's going to give me the vector with the unit part of it times my magnitude. Okay, so cosine of 135 obviously is on the unit circle. So that's going to be, let's see, negative square root of 2 over 2, right? And then sine is going to be positive square root of 2 over 2. Okay, so I have that part, and then I'm just going to distribute this 2 so that my final answer is negative square root of 2, positive square root of 2. And remember your vector, just like, let's go back up to this PQ. Remember that vector is your point. So you could write it like this, or you could write it in the I and J form. Either way is fine. Okay, so on this one, we are going to find the magnitude, so the length and the angle when given a vector. So do you guys remember how to find the magnitude? Think about Pythagorean theorem. So we're going to square this and square this. So I have 25 plus 16. And we're going to take the square root of that. So our magnitude is the square root of 41. So this is what we have so far. I wanted to give you a visual of what we have. So when we're trying to find the direction angle, I want that angle right there. That's what I'm trying to look for. So, you know, just however you want to do it, you can use sine, cosine, or tangent because we have that right, sorry, that looks hideous, that right triangle there. So you're just going to use like the inverse sine, cosine, tangent, get this angle here, and then subtract that from 180. So see what you can do with that. So I just did sine because I didn't want to mess with like the negative and having to figure out if I wanted it positive or negative or not. So I just personally did sine on that one because I knew that sine was positive in quadrant 2 still. And so I got that my theta for part of my right triangle is 38.66, but don't forget we're wanting that the outside angle there. So I'm going to take 180 minus 38.66 degrees, and I end up getting 141.34, and this is my directional angle. So magnitude, directional angle, and we are done. Okay, so for this next part, we're given the magnitude, so we know that the length is 14.5, and we're given the directional angle, and we're trying to find the horizontal and vertical component. So really, it's just the same thing. This is horizontal component X, right? And this is vertical component Y. This is very similar to the one that we did 2 problems ago. So I set up graphically what it's going to look like, and then we're just going to take the magnitude times the unit vector. So even though 220 degrees isn't on like our official unit circle, we're still going to, because it is part of the unit circle, we are going to still like take the cosine of 220 for my X value and the sine of 220 for my Y value. And sorry, I'm doing coordinate. So it's going to look like that. And then I'm just going to find each of these and then multiply them by 14.5. So go ahead and do that. Okay, so you should end up with this as your final answer. Okay, so we're going to again do the same thing. I'm going to turn you loose on this one. So nothing different, but just notice the difference in angles. Okay, so notice that 135, we just had one like this. It's still, I mean, that is part of our like special angle unit circles. So I'm going to use like the exact value on that. So I end up with -4 square root of 2 and 4 square root of 2. Okay, we are going to put this in a word problem. So we have two forces of these two different newtons acting on a plane, and the angle between them is 76 degrees. So think more geometry than physics. So I'm going to show you what this looks like. Okay, so we have this so far, and I'm going to go up to the very beginning, and right here on this graph, notice how I like put these to tips. Well, if I like extended this out and made a parallelogram, that is another way to get my resultant vector. So I'm going to show you here. So I'm going to draw a parallel line here and a parallel line here. And when I say parallel, like these two are parallel and then these two are parallel. Okay, and so it's going to make, it looks like a square. I didn't mean for it to be a square, but I'm going to make this parallelogram. So it looks like that. And so I'm going to fill in all the pieces that I have. But the reason I'm doing this is because this length right here is going to be the resultant vector. That's going to be what I'm looking for. So I'm going to call that V. We've talked about these problems before. So if this angle and this angle is 76, then I'm just going to take 180 minus 76 to get the other two angles. And so that ends up being 104. So then it should be pretty easy. I'm just going to use a law of cosines to find that missing side length or the missing length. Notice as I cut the 76 in half, or, you know, like we don't know exactly what those look like. I didn't mess with that one. I messed with this. So this is my side angle side that I worked with to get that vector. But other than that, that's it. Okay, now we're going to go on to vector multiplication. So we have two types. We have dot product, which is focuses in 2D, and cross product, you can do 2D or 3D. So we're not going to get to this today. We're going to focus on the dot product. And so the dot product is really simple. So what you're going to do, you're going to take the first, like the x components, if you will, and you're going to multiply those together, and then you are going to add them to the product of the y components. And we are doing this because dot products are used to find the angles between the vectors, and so it is really important that you're able to do this, and it's really pretty easy. The answer to a dot product itself, it's not going to be an angle. We're going to use the dot product to find the angle, but this is just going to be a scalar. So you never have to worry about like direction or anything like that. So let's put this into practice. So we have this one. So we're going to say -5 times 2, -2, sorry, is 10, and then plus 2 times -4, -8. So my dot product for those is 2. So try this one on your own. So this doesn't really tell us anything right now at this point. I'm going to teach you how we can use that. But anytime you have a 0, that means that your vectors are going to be perpendicular to each other. So the vectors are perpendicular to each other, and that is called that the vectors are orthogonal. That means just that it's a fancy word that they're perpendicular. So you're going to see that in your homework assignment. That's all that means. You're looking for perpendicular angles. Okay, so now let's put this all together. So notice we have that dot product on top, and then we have the multiplication of two magnitudes there. So we have everything that we can, or everything that we need. So this shouldn't be too difficult. Okay, and so think about theta. It's always going to be between 0 and 180. So we're stuck in those first two quadrants, which makes it a little bit easier. We don't have to worry about all four quadrants. Okay, so the first thing to find the angle between the two vectors is we are going to find the dot product. So go ahead and find the dot product. Okay, so you should have gotten -16. I showed my work here. And then don't forget the magnitude. We are going to kind of do Pythagorean's theorem. So I have 25 and 144. So the magnitude there is 13. And I have 16 and 9. So the magnitude there is 5. So we have a really nice number. So I'm just going to put 13 times 5 on the bottom. And so my fraction that I came up with is -16 over 65. Okay, so I'm not done yet. I don't know why there's two cosines there, sorry. So we have to find the angle, right? So I'm going to say the cosine of theta equals -16 over 65. So to find theta, I'm going to say cosine inverse of my angle. And I get that theta is 104.250 degrees. Okay, so go ahead and try that one. Okay, so I showed my work here. You should have ended up with this, and don't worry about rationalizing it because that's not my final answer. I have to put it in, to this formula anyway, and so that's my final answer. So you can just keep it yucky if you want to. And we are done.